Okay, here's our first review. We'll try to get as many of these done as I can. I don't know if I'll get 10 of them done in this amount of time or not, but we'll give it a shot. It says, look at the first one. The ratio of the measures of three sides of a triangle, 9 to 6 to 5, and its perimeter is 100 inches. Find the measure of each side. So first thing we're going to do is we're going to actually solve for x. We'll show you how to set it up. We'll solve for x, and then we can find the measure of each side by taking 9 times x, 6 times x, and 5 times x. Woo, excuse me. Thank you. Hope I don't start sneezing like crazy. Alright, so what is it? 9 to 6 to 5, right? 9 to 6 to 5, and the perimeter was 100? Okay. So this is what we do. We just go 9x plus 6x plus 5x. Now what is that? That represents the length of one of the sides. This represents another length of the side, so does this. The perimeter is 100, so all three of those lengths add up to be 100. So now we just solve for x. What's that? 15, and that's what, 20? X equals 100, and what's that, 5? So x is 5. Is that my answer, though? No, because it says find the measure of each side. So remember, this is one side, that's another one, that's another one. So all you do is just 9 times 5, which is it's 45, and then it's 30, and then it's 25. So that right there is your answer. That's number 1. It's a Chapter 7 test. All right, let's take a look at number 2. All right, so it's right here. We just have to solve for x. We're going to do a little cross multiplying, and let's write that down. So it's 3x plus 1 over 14 equals 5 over 7. All right, so it's just a matter of cross multiplying and solving for x. The key here is to understand that when I multiply this by 7, you got to keep that in parentheses because we have to distribute that 7. We'll do that in a second. And then that equals, I don't know, what's 14 times 5? Somebody do that. 70? Okay, good. Oh, you know what I could do right now? I could distribute the 7, but I see something. Do you see a little shortcut? Divide both sides by 7. So if I divide this by 7, look what I get. You don't have to do that. It doesn't work every single time. But in that case, I just saw it and it works real nice, doesn't it? Everybody see that? Subtract 1 from both sides, so 3x is 9. Divide by 3, x is 3. And bang, I'm done. That's all there is to it. Number 3. Same thing, right? Same exact thing. Just cross multiply. So it's x minus 3 over 4 equals x plus 1 over 5. Now remember, the only time you cross multiply is when you have an equal sign in between. I can't remember what class it was, but I remember somebody this year tried to cross multiply when it was an actual multiplication problem. You don't cross multiply, do you, when it's an actual multiplication problem? You only cross multiply when it's a proportion, when two fractions are equal to each other. Make sure you understand that. So that's 5 times x minus 3 equals 4 times x plus 1. Distribute. Now in this one, there's no little trick that I could do getting rid of that 7, so I'm going to have to distribute here. So it's 5x minus 15 equals 4x plus 4. Well, this works easy. Subtract a 4x from both sides, that's just an x. Add a 15 to both sides, that's a 19, and then there you go. Easy as that. Don't you wish they were all that easy? Okay, number 4 is kind of like number 1. We're kind of going to go through the same process here. Except it's what? It's angles, right, instead of the lengths of sides, right. Okay, so let's take a look at that one. It says, find the measures of the angles of the triangle if the ratio of the measures of the three angles is 5 to 4 to 7. Now look up here. They told you what all this stuff added up to be, didn't they? They said the perimeter was 100. So I went 9x plus 6x plus 5x equals 100. Now they don't tell you what they all add up to, but they do say they're the angles of a what? Of a triangle. So you should know what all those angles add up to. Well, they add up to 180. They add up to 180, okay? So that's the key there, is to understand that. So our ratio is 5 to 4 to 7, right? 5 to 4 to 7. And they're angles of a triangle. So that means that would be one angle. That would be the measure of the second angle, and this would be the measure of the third angle. All the angles always add up to what? 180. So that's the key there. That's really the only big difference between this and the first problem that we did. So that's 9 and 7, which is 16. This comes out even, doesn't it? It doesn't? Okay. What's it come out to be? Okay, so 11 1/4. Or you could have simplified it. I don't really care how you write the answer. You could have written it as a fraction. You could have written it as a improper fraction. As long as you simplify it, okay? 11.25 is fine. 11 1/4, you could have kept it improper, whatever. It's perfectly fine. What's that? That's not the answer? What is it? Oh, got to plug it back in. Thanks. See, I was just checking to see if you were paying attention. Not really. I just completely forgot. So what do? You take this, and you got to plug it back in for this. So somebody have those answers in front of you? So it's 5 times 11.25, which is what? 56.25. And then 4 times this, right? Just 45? Okay. And then 7 times this. 78.75. Okay. Good. Those are your 3 angles. Those are all degrees, right? Because they're all angles. And they should add up to 180 degrees. You can do that on your own. Hopefully they do. I would venture to say they do. All right. Number 5. Let's take a look at that. Number 5 says 2 similar squares have a scale factor of 2 to 5. It says the perimeter of the large square is 45. Find the perimeter of the small one. Let's think. Do we need to draw a picture on this or not? No. No, because if you remember, we have a theorem. I forget exactly what it says, but it says that the scale factor of the sides is the same scale factor as the perimeters. It's not true about area, because we just finished learning something about area, didn't we, in the last chapter, in chapter 11? That the square of the sides is proportional to the ratio of the areas. But that's not true about perimeter, though. So the scale factor is 2 to 5, and so and it says the large one is 45 inches. So let's go to this. So the ratio is 2 to 5, but the perimeter of the large square or rectangle, what do they say? It's a square, isn't it? Is what? 45. So I need to write some kind of proportion here. So if I compare, and what are we trying to find? We're trying to find the perimeter, aren't we? Of the small one, of the small, equals question mark. Okay. Well, let's do the math. Okay. I'm not really that concerned about what the answer is right now. I'm concerned about how to set the thing up. Okay. That's what I'm concerned about more than anything. So what could we do? We're trying to find the small, right? So let's find, I'll put PS for perimeter of the small. Is that all right? So the perimeter of the small, if I compare the perimeter of the small to the perimeter of the large one, which was 45, then what's this ratio? That's the small, and this is the large, isn't it? So 2 is going to go on top, and 5 is going to go on the bottom. Does that make sense? Yeah. You can paper towels up there. All right, so now what do? You could cross multiply, but 45 is on the bottom. So what do? Just multiply by 45. And then the perimeter of the small is, whatever that is, 90 divided by 5. What's that? 18. 18. All right. Is that the answer that on the test? Okay, good. And that's all there is to it. That's the perimeter of the small square. All right. Let's keep going. Oh, my goodness. It'd be nice if I could copy and paste this, but I cannot, because it's a PDF file. Anyway, here we go. Let's just set up our proportions. We'll talk about it up here, and then we'll see. It says, first of all, are these similar figures? Well, they don't. They probably. I should have said that these are similar figures. I think we're kind of. I don't think we can tell just by looking, but I think that's the assumption that we have to make, that they are similar to each other. So we want to solve for x. So we need to set up some kind of a ratio, some kind of a proportion. Since the 2 angles are proportional to each other, like 2 angles, they're not in proportion. They're equal, right? No, you got to show all of them. And I don't think there's really a way to do that. I think we have to make an assumption that they are similar to each other. Okay. Now, if it was a triangle, then that would be true. All I need are 2 on a triangle. But on here, I would need 3 of the 4. Okay. If I knew that all 3 were equal to all 3 over here, then I could say it was similar. But I think we're just working on the assumption that they are similar. So let's do the numbers right here. How are we going to set this up? Let's find the scale factor first. Look at the 2. What is it opposite? It's opposite that side between the two angles, right? So the 2 and the 3 do match up with each other. They do correspond to each other, don't they? See, they're in the same spot. So I could go 2 to 3. So let's do that. So we're going to go, let's try a different color. And what number is this? 6. Let's go 2 to 3 and see what that's equal to. If I go 2 to 3, what about this one? This is opposite. Yeah, you could say it's opposite the one with 2 arcs, right? This is opposite the one with 2 arcs, so those two go together. So it's x plus 3 over 2x plus 2. So it's x plus 3 over 2x plus 2. Do you see that? The 2 and the 3 go together. They match up. They're corresponding. The x plus 3 matches up with the 2x plus 2. They're corresponding. So you write a proportion out of that, and now you just solve for x. So we've done this earlier today. So what's that? I'll tell you what. Let's just go ahead and do the multiplication, right? So that's 4x plus 4, and that's 3x plus 9. Subtract a 3x. That's a 1x. Subtract a 4x is 5. And that's all you need to do is just solve for 5, or solve for x, which is 5. We good with that? All right, I hope. Let's go to this one, number 7. Say what? 40. So find the perimeter of this triangle DEF if the two triangles are similar to each other, and all this stuff is true right here. So you could draw the triangles out if you wanted to. I mean, it doesn't have to be like perfectly a scale or anything. If that helps you out, I don't know, let's say like that, okay? So let's say that and this. Let's make that a little bit bigger. Oops, missed a side, didn't I? That's all right. Let's just take a look at it. Which one's bigger? Is a ABC. So AB and DE. AB is 5, DE is the corresponding one. So the ABC is the bigger one, right? So this, what did I say, ABC? And then DEF, is that what it is? Yep. And then DEF. DEF. Notice that the A and the D have to go together, right? Because they said triangle ABC is similar to triangle DEF. So the A and the D have to match up, yep. The B and the E, yep. And then the C and the F, they have to match up, that's true. Alright, so let's put some stuff in there. So AB is 5 and DE is 3. AB is 5 and DE is 3. And then what else? BC is 6. BC is 6. And then it also said that AC was 7, correct? Is that everything? 5, 6, 7, 3. Yep. And what are we trying to do? We're trying to find the perimeter of DEF. So we're trying to find the perimeter of this. So basically, the perimeter is the easy part. What do we have to do? We got to find that side, we'll call it X, and we got to find this side, we'll call it Y. Make sense? So first thing we do is find a scale factor. 3 to 5, good. Okay, so 3 to 5 is our scale factor because I know this side and I know this side. That's my scale factor. So now if I want to solve for X, I just set up the corresponding ratios. That's pretty easy, isn't it? So what would it be if I want to solve for X? X to 6, right? So I just go X to 6. Solve for X, multiply both sides by 6, and that's 18 over 5. So X is 18 over 5. What's the thing for that? The decimal. That would be what? 3 and 3/5, 0.6? Okay, so 3.6 we'll say. Alright, that's what X is. What about Y? Well, use the same scale factor. Use that 3 to 5 again, and then it's going to be what? Y to 7. Alright, multiply both sides by 7. That's 21/5. And that's 4 and 1/5, which is 0.2, right? 4.2. Okay. And so now what do? I just take the 3. I want to find the perimeter of this, don't I? That's the question. It doesn't say just solve for X and just solve for Y. It says find the perimeter of this. So I got to add them all together. So it's 3 plus 3.6 plus 4.2. And I should be able to do that in my head. That's 0.8, right? And that's what? 10? Okay. 10.8. And there it is. There's your perimeter. Coming back to you? Yeah, it's been a while since we've done these, but see Seems a lot easier now, doesn't it? Than when we were doing it. I don't know. Maybe. What's the next one? Oh my goodness! Look at this crazy thing. Let's draw that thing out. It shouldn't be too hard. Just take a second. So it looks like this, like this, like this, like that. Alright, and I'll just stick the numbers in. That's 15. This is 7x minus 9. This is 24. And this little bit is 12. And the middle one is 18. And these are parallel to each other. 1.8. I can't read. Let's put a little space in there. 1.8. That makes... Is that right? Oh, you know what? I think I put 1.8 in here, but I changed it because I don't think it was supposed to be 1.8. So I changed it to 18. It makes it a little bit more... Because look, if that's 15, there's no way that's 1.8. Would you agree? So that was my bad on that. But I gave you the answer. Whatever you got for 1.8, I gave it to you, but it just didn't make sense as far as the picture. I'm not saying that all pictures are going to be exactly proportional and to scale, but that was really, really way off. So I actually changed it, I think, after I gave you that test, and I made it 18. Is that all right? That's not going to bother you, is it? All right, so what are we going to do here? What are we trying to find anyway? We're trying to find RT. Let's put some letters in here. RT. This is SQ. And this is V. So we are trying to find, on number 8, we're trying to find what RT is equal to, and number 9, we're trying to find what SV is equal to. Alright, well let's see. RT, this thing right here. So what we're going to have to do, this one's a little bit trickier for you. I want to find, I'll just call this, I don't know, I'll just call this A. Is that alright? Just so I don't have to say RT all the time. I'm going to solve for A. So what I want to do is I want to make a ratio. I want to go A to, I don't know, 18, right? Compare, now watch what this is though. This is a full side of this big triangle, and 18 is a full side of this smaller triangle. Everybody see that? So when I'm going to have to make a comparison, I'm going to have to compare an entire side to the big triangle to the entire side of a small triangle. A lot of people probably did this. A lot of people probably just said, oh, 12 to 24. But is 12 the entire side of a whole entire triangle? No. If I'm going the big to the little, I'm not going to go 12 to 36. I'm going 36 to 24. Okay? And so that would be this answer right there. And there you go. All right? All right. We'll do more tomorrow. Okay? I'll stop right there. I may finish this up in the other class, so if you want to see the end of this, watch the other video. All right?